So here is the bottom part, which is obviously the table and the riser. As I said, hopefully I'm not going to have to do too much work on this. I'm certainly considering making a new table. Looking at it, it looks like it's pinned to this shaft. There appears to be a pin right there. And so hopefully I can take that off, and it shouldn't be too much of a problem machining up a new table. All of this is just like tin plate, nuts and bolts and screws, so it all comes apart. It looks like it all comes apart fairly easily. So yeah, let's get it stripped down. So here's the bottom end all stripped down. All came apart very nicely. The guide pin was actually threaded into the hole on the table, so that was nice. That makes fitting it into a new one, should I decide to make one, and I think I will. You know, this is just mild steel. It's just a matter of turning up a new one without, which won't have all of these holes in it, which would be quite nice. Yeah, it all came apart really easy, so I'm just going to need to clean everything up, work out what we're going to do for the handle, a new table, and that will be the bottom end done, and we can move on to the back pulley, you know, the main drive pulley. Well, in the end, I definitely decided to make a new one of these, the table for the Goodell-Pratt drill press. So to that end, I've got a nice piece of 2 3/4 inch mild steel stock chucked up in the vise, and I'm not going to show you the machining of this. Is very straightforward. Basically, we just turn into a shoulder. We've got to make that boss in the middle. We've got to drill. I might show you the drilling, how I do go about drilling this hole and tapping it. But for the most part, this is really bog standard basic machining. But I thought you might like to see my new toy, which I bought for the lathe, and this is the very first time that I've actually used it. This is a self-centering 4-jaw chuck, and it's perfect for this kind of work. For my little tiny lathe, this is a very large, heavy piece of metal, and whilst I could hold it in the 3-jaw chuck, the more jaws you got clamped onto it, the better it is, basically. I mean, that's a given. If I had a 6-jaw chuck, I'd use that. But no, this is heavy for my lathe, and you know, it's going to be rotating not very fast at all. This is another problem. Again, this is a whole feeds and speeds thing. This is 2 3/4 inches. The correct RPM for turning the outside of this is approximately 145 RPM, which is ridiculously slow, and my lathe's got no torque at that kind of speed whatsoever. Now, I'm going to be using carbide tooling, so I can increase the speed for that, but even so, I will have to, probably about the minimum I can get away with, will be about 300 RPM on this for turning this, and it should be fine. I'll use cutting fluid, and I've already done a couple of first cuts across the face here, and also I will be you know, center drilling this, and it'll have tailstock support as well when I do the main part of the turning. But yes, I bought this self-centering 4-jaw chuck. Wasn't horrendously expensive, but it was just what I wanted for jobs like this, where I've got something heavy that I really need extra clamping force over the 3-jaw. And yeah, it's a nice bit of kit. Comes with 2 sets of jaws, inner and outer. I've got the outer type jaws on at the moment, but yeah, it's a nice bit of kit. Anyway, I thought you might like to see that. A lot of people obviously poo-poo self-centering 4-jaw chucks, but you know, when you want to hold something like this, it's just ideal. It really is. You know. So I'm going to get on and do this, and I might show some of it. I'll see how it goes, but it's going to take me a while because obviously I can't take heavy cuts on my lathe, not on steel. So it's going to take a while, but thought you might like to see that. Alright, I'm going to show you a little bit of the machining. After a bit of experimentation, I discovered that around about 500 RPM is the best compromise I can come to with the machining, because that gives the lathe enough torque to actually maintain speed, and also I can take a reasonable cut, but even so I still can't take huge cuts. Okay, well, we're gonna give it a go, and I'll show you what I mean. And that actually gives a good finish on the steel at that speed. I don't know how well you can see. That's changed the camera angle slightly. Yeah, there you go. You can see a bit better now. So that actually quite good. That gives a nice finish on the steel at that speed with coating fluid. I've got a bit further to go to create enough depth for the boss, but we are getting there. As I said, it's not the right ideal RPM to get the correct cutting speed, but it works and it stops the lathe from stalling out, which is great. So I'll keep on at this and I'll bring it back later. The new table for the Goodell-Pratt drill press is nearly finished. What I've got to do is drill and tap this hole here, which is for the guide rod. Now, I've been looking at the pictures, the photos I took of it when it was assembled, and it suddenly dawned on me what that rod is for. It's not complete, but I believe that rod is a depth stop, or in this case, on this particular drill press, a height stop. So you can lock the table at a certain height and then repeatedly drill holes at the same depth. That's what I think it's for. So this is my setup anyway for drilling longitudinally on the lathe. Very similar to the cross drill block, except it's designed to take a chuck in that direction. And it means it allows me to drill anywhere on a circle of anything that is in the headstock. So I've got it set up. There's a 5mm spot drill in there. I've got my mark. It's all lined up on the new table, and I'll spot drill that, and then I will drill it tap-in drill size for 1/4 BSW, which is what the thread is in the original. Now I'm going to have to make a new rod because having had a close look at the original rod, it's bent. So that's no bloody good. So we're going to have to make that. But I just thought you guys would like to see this set up, how this works, you know, and yeah, basically that's pretty much it. It's standard flexible drive to a drill, and that really is it. So we'll just spot this one. And I'll change that out for the appropriate tapping drill, and we'll do that, and that'll be done. And then it's only a matter of cutting this off. What I'm probably going to do is use the parting tool to take this down to about 2 inches. Then I'll transfer it over to the power hacksaw and do the rest of it on the hacksaw. The little table is finished and has been refitted along with all the other components of the bottom part of the press. Let's come and have a look at that a bit closer. There we go. Let's move that around a little bit so you can see that better. Yeah. Now, it's interesting as you go through with these things how much more work is involved than you actually initially think. Obviously, I remade the table, and what I've also done on here is when I took it apart, I noticed that this little block here, which I've now decided is the height stop, was shimmed out from this part of the casting. There were 2 little lumps of metal that had been placed between the block and the casting. And here's the original put out. When I look at this, not only was it not really big enough, as in wide enough, but also the hole that was through the middle has been drilled at an angle. So when I remade the depth stop pin there, obviously I made it straight because the original one was bent. That's why I remade it in the first place. So I decided to make a new block. So we've got a new block on there, and that all works fine. Now, I'm convinced this was depth stop or height stop, whichever way you want to look at it now. I don't know how it was originally done, but I've added this little slider with an old screw so that will act as a stop for the table. Now, this is my best guess at possibly how it was done. I don't know. It may have even been added by somebody else. It may not have been on there originally. I honestly don't know. But that's been done. What else have we done? Oh yeah, in between the 2 parts of the lever mechanism here, there was a spacer, but they just used a nut. So I've turned up a proper spacer there. I've replaced all the bolts. The pivot pin through here, where the handle pivots around, or the lever pivots around, this was originally just a screw, a bolt. So I've made up a proper pivot pin. There's now a proper pivot pin in there. I was really a bit of a loss to know what to do about the handle, but I found in amongst my supplies of scrap aluminium an old peg spanner, which I'd obviously fished out of a scrap bin somewhere. So, and it just so happened to be, it was almost exactly the same size as the 2 side pieces that make up the lever here. So I cut a bit of that, and I've got no idea on the length. That seems to be about right, gives a reasonable amount of control and leverage. So I don't know. I don't know whether that's correct or not, but it works, and this is now all finished. There's no play in this at all. There's no play in that. So yeah, it's coming along. So what next then? Well, I think that the next object for attention is the column. We need to clean the column up. That's just a wire wheel job, I think. And the base, I may well paint the base after I've cleaned it up and de-rusted it. And obviously this nut here and the bracket as well that holds this pulley. So yeah, so we'll concentrate on that next, and then finally we will do this part here and sort out some sort of motor drive for it. But that's where we are at the moment.